welcome back. Now let's work on morphing animation. First of all, what we'll need to do is switch from points material to shader material. Why? Because the animation will require us to use some shader logic, and to use shader we have to pass shader material here. We don't need these. For better coloring, we'll pass blending and additive blending, and then vertex shader and fragment shader. Right now, these are not imported from anywhere. So let's create shaders folder. Then similarly, we'll create a fragment shader. In vertex shader, we'll add a very basic code. So you should know this boilerplate. I'm not going to explain it here because otherwise it will take a lot of time. Similar to this, we'll add code in fragment shader and then import a shader here. We have shaders inside model loader. If we refresh here, it will give some error, which is fine because we have missed some extensions. Now it is still showing nothing. If we go to console, it will say unexpected token vertex shader.glsl. So what does that mean? This means like our current React project is not able to understand the GLSL extension. And for that, we'll need to install this plugin. If you are using white, then this will work. Otherwise, you have to check a similar plugin. I have installed that plugin already, so I'll just quickly go to the next step, which is importing it here. And using it inside plugins. Now, if I come to my code and refresh, we are not getting such error again, although this look very weird, which will fix quickly by adding this line. So this is telling Three.js to put the point size as 0.2. Then if we refresh here, we will see the model is loaded perfectly. Now next step will be sending more positions to vertex shader. We'll do that by this. So now vertex shader have attribute containing position value of A, B, and C. We can use that inside shaders using there's one problem though. If we log the value position of each model, see this array, you'll see the count is different. We have 6,000 and 9,000, 4,000, 2,000, and we want particles to animate and create these logos. For the best result, it is wise for all the models to have the same count. For that, we'll give each model a maximum number of vertices where initial vertices will be same and the last vertices that we have added will have duplicate values. So to normalize, first we'll need to have max count and then loop that will add padding. For max count, this will work. Here we are looping through each item and using max.max to give us a max count value. And this variable is where we will be storing the particle position. Here we are just going from each child mesh and then create new array which will be 3 times of the maximum vertex count because each vertex will have 3 properties x, y, and z. And in this loop here we are checking if current count is less than the source actual vertex count, then set those vertices directly from the source. Otherwise, for padding, we are calculating a random vertex and then adding it into the new array. Random vertex will be taken from the source array. After that, we'll need to update here. Now for morphing, we'll create a variable called mixed positions that will mix the actual position with second position, and we have to tell the amount of mixing, which is only 10% for now, and we have to take it here. You see, we are passing mixed position, and the fourth parameter is 1, which is alpha, and we should not forget these semicolons in the end, otherwise it will give us syntax error. This will create a view position. Now we'll just need to multiply this with projection matrix here and then refresh. Now there is some syntax error. Yeah, there was a typo here. Now if I close this, you will see that this GitHub logo is distorted. That is because we have mixed it with the A position. Now if I change the intensity, you will see it is almost gone. Now let's put it as 100%. Now you will see it is git code logo. And if I pass 0, then it is 100% GitHub logo. So now almost 90% of task is done. We will just need to pass this value, which will go from 0 to 1 based on the scroll. For that, we can go to featured section. And here we are using self.progress to set the index. But now we will just need to get the raw progress. Pass that progress here. Now we'll go to model and pass this progress to mesh. Now, in order to pass progress, we'll use uniforms. So we can pass it from here. We'll name it as u progress, and it will be an object that contain value, which will be this. We don't want use effect to run on progress update because then it will be doing all this calculation again. We just want to update the progress value. So for that, we have another hook from React 3 Fiber, use frame. We'll use this to pass the progress. So we have material. We'll remove console log from here. Then we have material here. So we'll store it in RF. So this hook is from React, which we'll use to access the points. You can also rename it as points only. Now here we will say point ref, then material, uniforms, new progress, value as progress. Let's see if there's any error. It seems he has some issue. Let's check. So here we'll need to pass scene. Let's see what else, what other dependency we are using. That one is model and camera. Now if we refresh, we can see this again. It will be more efficient this way. And if we scroll, we cannot see anything yet because inside vertex shader, we have to get uniform using uniform and the type is float. U is just to show that this is the uniform value. And if we move it here, so now if you scroll, you will see particles animating, but the old position is not cleared. That is because use effect is triggering multiple times, which is creating multiple geometry and then adding it to the scene. So we have to give it cleanup function, which will tell it to remove points on cleanup. Also, good thing is to dispose of the geometry variable and material. Now, if we come here and do the scroll, you'll see the animation is working perfectly. Now, if we come back to the portfolio, you'll see here we are animating multiple objects. That will be a simple if condition here. Based on that, we'll be passing these positions. So I will encourage you to do that on your own. Otherwise, in next video, we'll be rendering position A, B, and C to achieve the final effect. See you there.